Example number 3, light intensity data for a 100-watt light bulb. Find the relationship. We want to find what the relationship is between the intensity and the distance. We want to linearize that data so we can develop a mathematical model. In other words, we want to find out what the relationship actually is and develop an equation to allow us to apply the model to figure out what the intensity of a 100-watt light bulb is from 5 meters away. Now, the first step in this process, in order to come up with your mathematical model or your equation, is to identify what type of relationship this is. So on the bottom left-hand corner, we can see kind of the 4 common relationships we have. And if we look at this, we can see that this appears to be either an inverse or an inverse squared relationship. So what we're going to do first is we're going to take the simplest one, inverse, and we're going to test that. So we're going to manipulate the data on the next page and test that idea. Again, I'm not going to show you all the graphing, but I will walk through the manipulations with you. So what we're going to do here is we are going to take the distance, since it's on the x-axis, and plot 1 over the distance to see if an inverse relationship is the actual relationship that exists between the intensity and the distance. This is a test, so if it turns out to be a straight line, that means the relationship holds true. If it's not, we chose the wrong relationship and we will have to go back and try another relationship. So when we take the inverse of the distance each time, we get 1.667, 1/2, 0.4, and 1/3. So we will plot that data now and see what we get. So after we plot the intensity on the y-axis and 1 over the distance, the inverse of the distance on the x-axis, we can see that it doesn't appear to be inverse anymore, but it doesn't appear to be linear either. So while we're on the right track, it's still not the correct relationship. So what we're going to do next is we'll take, if we go back to our original data set and look at this, the other option here would be an inverse squared relationship. So what we are going to do on the following page is we are going to manipulate the data. So you have 1 over the distance squared, and then we will plot that and see how the graph differs. If it becomes a straight line, we can create a mathematical model and move on. So now that we've plotted our data, we can see that the intensity is related to 1 over the distance squared. It's an inverse squared relationship because we get a straight line. So now what we can do by it passing the test, now we have a straight line. We can write an equation for the intensity as a function of 1 over the distance squared. So the way we do that is draw a best fit line and take 2 points to find the slope. Sliding over to the next page, okay, I drew a best fit line in green. You can see the 2 points chosen. So what we're going to do is the calculation of the slope here, which is going to be 7.95 watts per meter squared is another name for that is lumens. You might have seen that if you bought a light bulb recently at Home Depot or Lowe's. They got rid of the watt rating and have converted to lumens, which is just a measure of brightness. So 7.95 minus 2.01 divided by 1 minus 0.25. It's 1 over meter squared. So when we look at this, all right, we find the slope to be 7.92. And the units here would be lumens times meter squared. Okay, so our equation for this, our model, is going to be the intensity is equal to 7.92 lumens meter squared times 1 over the distance squared. Now we can use that model to predict what is the intensity of a 100-watt light bulb from 5 meters from the observer. So that was a question we started with here. So I is equal to 7.92 times 1 over 5 squared. And then when we calculate that in, we will find that the intensity is equal to 0.317 lumens. Okay, so this is how you go through a process where you first guess you don't necessarily get a straight line, and you have to go back to the drawing board and try another function. From there, we linearize